Imagine standing in a desert, where the surface temperature reaches 50 degrees Celsius, where the air is so dry and hot it feels like it is burning your skin with every breath you take. And yet, just beneath your feet, hidden deep below the sand, there is solid ice that has been preserved through the peak of summer without a single watt of electricity, without compressors, without refrigerants, and without anything we associate with modern cooling systems. More than 2,500 years ago, in ancient Persia, architects and engineers created something so advanced in its understanding of thermodynamics that it still challenges our assumptions about what is possible. They built structures called yakhchals, which literally functioned as desert refrigerators. And what makes them extraordinary is not just that they worked, but that they worked in one of the harshest climates on Earth, using nothing but earth, wind, and physics. At first glance, a yakhchal looks almost like a monumental mud dome rising out of the desert. But what you are actually looking at is a highly engineered thermal system designed to manipulate heat flow at every level. The dome itself was constructed using a special ancient material called sarouge, a carefully balanced mixture of sand, clay, lime, ash, and even goat hair, which created a surface that was not only incredibly strong but also highly resistant to heat transfer and completely waterproof, effectively shielding the interior from the burning external environment. The shape of the structure was not accidental either. The dome was built in a precise parabolic form, which is one of the most efficient geometries for thermoregulation because it forces hot air, which naturally rises, to accelerate upward and escape through the top vent, continuously pulling cooler air from below and maintaining a passive airflow system without any mechanical assistance. Meanwhile, the base of the structure featured walls so thick they acted like a massive thermal battery, absorbing and delaying the transfer of external heat so effectively that the interior remained insulated, even during the most extreme desert afternoons. But the real genius of the system came from its integration with wind. Ancient Persian engineers built tall structures known as badgirs, or wind catchers, which functioned like natural air funnels. These towers captured high-altitude breezes and directed them downward into the subterranean chambers of the yakhchal, where the air was forced to pass over underground water channels. As the air moved across these cool surfaces, it lost heat through evaporation, dropping in temperature dramatically before circulating through the storage chambers below. This is where the physics becomes even more fascinating, because the system relied entirely on natural pressure differentials and fluid dynamics. Warm air, being less dense, naturally rose and exited through the top of the dome, while cooler, denser air sank and remained trapped in the lower storage chambers, creating a continuous cycle of airflow without any moving parts whatsoever. Deep underground, the yakhchal took advantage of one of the most fundamental principles of thermodynamics: radiative cooling. At night, the structure would release absorbed heat directly into the clear desert sky, which acts as a thermal sink, allowing temperatures inside to drop significantly, often reaching freezing conditions. During winter, ice was collected from nearby mountains or frozen pools and transported into these chambers, where it was carefully layered with insulating materials like straw and kept intact for months. Even through the peak of summer heat, what makes this system even more remarkable is how it completely contradicts our modern assumption that refrigeration requires electricity or chemical coolants. Instead, it shows that, with the right understanding of physics, heat transfer, airflow, and material science, it is possible to build a fully functional cooling system that operates entirely off-grid, with zero emissions and zero energy input. When you compare this to modern air conditioning systems, which consume enormous amounts of electricity and contribute significantly to global carbon emissions, the contrast becomes almost uncomfortable. Yet what is even more interesting is that these ancient principles are not lost. In fact, they are being studied and reintroduced into 2026 sustainable architecture, where engineers are once again designing buildings that use passive cooling, wind capture, and thermal mass to reduce energy consumption in rapidly warming cities. And perhaps the most powerful takeaway is this: some of the most advanced climate solutions we are searching for in the future may not be inventions at all, but rediscoveries of knowledge we already had thousands of years ago, hidden in structures like the yakhchal, waiting for us to understand them again. What do you want to see next? Let me know in the comments, and subscribe for more videos like this.